Hi guys, this is Mr. Grabakis. So today we're going to be focusing on equations and inequalities. So you guys will be able to solve absolute value equations and inequalities by the end of this lesson. So now we want to talk about the inequalities. So we're going to utilize some of the same rules as the equations, but then we have to take into consideration a few other things when dealing with the inequalities. So when you're dealing with the absolute value and inequalities, what makes this situation true? So we have the absolute value of x is greater than 5. So what kind of numbers make that true? So if I were to plug in, say, a -7. If I were to plug -7 into this equation, is this true? It is, because what's the absolute value of -7? 7. And 7 is greater than 5. So what happens if I plug in -3? Is 3 greater than 5? No. What happens if I pick a number like 2? Is 2 greater than 5? No. And then what if I ended up picking 6? Is 6 greater than 5? Yes. So it looks like the larger the negative numbers are, make it true, and the larger the positive numbers are, make it true. So what happens is the rule that we have here is you, again, go through isolating your absolute value sign. When you are working with inequalities, if you have a greater than, or equal to, this is an or compound. And I'll show you what that looks like with an example. So what happens is the or situation looks like something like this. So if we were to have a number line, and let's say that we had, let's just use the example that we were using before where we had 5. Traditionally, you guys would use open circles, because if we were to plug -5 or 5 into this statement, it wouldn't be true. If we had an equals sign, then we would use solid. So we said that large negative values or large positive values would be what works with this equation. So the graph of an or is going to look like this. So once you figure out what the graph looks like, this can help you with interval notation. So we have the arrow going forever in the negative direction, which means that it's going towards -infinity. So your interval notation will follow your number line. So we have -infinity, and then the point where we take a break is at 5. Open circles are with parentheses. We have a gap. Anytime we have a gap, we use a U, which is a union symbol. We pick back up at 5, and then the red arrow goes forever in the positive direction, which means we have positive infinity. If we were to have absolute value of x is greater than or equal to 5, like I said before, we'd have these filled in. That would be the only difference on the number line. And then the difference with the interval notation would be very similar, except for instead of parentheses, we would use brackets. So your open circles are parentheses, your closed circles are brackets. So now what happens if we have the other situation? So we dealt with greater than 5 in the last one. What happens if we deal with less than 5? So let's do a few checks, right? So we checked -7 last time. Is 7 less than 5? Nope. What happens if we check -3? Is 3 less than 5? Yes. Then we did absolute value of 2. Is 2 less than 5? Yes. And then we checked 6. Is 6 less than 5? Nope. So what happens with this one is this situation is an and compound versus an or. So when you're dealing with less than or less than or equal to, you can rewrite it as an and compound equality. So what does an and look like on a number line? So if we were to, again, take the example, so we have x is less than 5, we would have the open circles again from here to here. But we saw that numbers in between -5 and 5 were working. So what happens is you have this situation right here. What does that look like from an interval notation standpoint? Well, no arrows to -infinity or infinity. Instead, we have the overlap piece here. So that means that because of an open circle, we have a parenthesis at -5. And then we travel to 5 with another open circle. So that means parenthesis. Again, another hypothetical, if we were to have a less than or equal to 5, we would have filled in circles instead of open circles. And we would have brackets for interval notation instead of parentheses. So your ands are going to look like this. Your ors are going to face away from each other. So let's practice 2. So we have this absolute value. Again, we want to isolate first. So that means that we want to divide by -3. Divide by -3. So we're going to get absolute value of x plus 1. Now be careful. This rule has applied for several years for you. Hopefully you guys remember from Algebra 1. If we multiply or divide by a negative number, our sign is going to flip. So because we divided by a -3, our inequality is going to flip. So we have a -12 divided by a -3 gets us a 4. So just like with the equations, we split this guy into 2 pieces. One as is, and one with the opposite value, which in this case would be -4. But keep in mind what we just did up top here. We divided by a negative. We introduced a negative to the other side. We introduced a negative to this side as well. So what's going to happen is not only do we have to do the opposite of the other side, but we also have to make sure that we flip this sign as well. So we just happened to flip the sign twice in this example. So then the other thing we have to identify is this an or an and? So you want to go off of this moment right here after you isolate the absolute value bars. So we are dealing with a greater than, so which means that this is an or. So you need to make sure that you indicate that as you're working through your problems. Okay. So now it's just our job to solve. So now subtract 1, subtract 1. So we have x is greater than or equal to 3, or x is less than or equal to -5. So what does this look like on a number line? So we have equal to's, which means we're going to have closed circles. We want greater than or equal to 3, or less than or equal to -5. Okay. So I'm not going to require you to graph every time, but the graph will help you set up your interval notation. So I am looking for interval notation for this. So now we have the arrow going to -infinity. We have a stopping point at -5. We have a closed circle, which means we have a bracket. There's a gap, so we use the U for union. We pick up again at 3 with another bracket. And then our arrow goes to +infinity. So this right here, we could consider a final answer. So now we have this equation, our last example. We're going to subtract 4 first. Now that we've isolated our absolute value, we want to split. One of them is the opposite. So we have 2x minus 1. We're going to have a -x plus 7. And then the new idea is when we do this for an inequality, we have to flip the sign. So our less than becomes greater than. So now we're going to go through and solve this as we normally would. So we have x is less than -6. There's one thing that I forgot to do between here in the beginning, and I apologize. We have a less than symbol. So a less than is an and. So I need to make sure that I write that because I need to make sure that my final answer looks like an and. So I have x is less than -6. Now I'm going to go through and solve this one. So as I solve that, I end up getting x is greater than 8/3. So if we were to think of this as a decimal for a second so that we place correctly on the number line if we were being accurate, this is 2 2/3, or roughly 2.67. So we're going to create our number line and then write our interval notation based off of this. So we have greater thans and less thans, no equal to's. So that means that we have open circles here. We want to be less than -6 and greater than 8/3. Okay, wait a second, pause. An and is supposed to look like this, right? But doesn't this look like an or? It does. So what happens is your ands are supposed to overlap. So if our ands do not overlap, then our answer for this is no solution. So this is a special case for you guys. So the other special case is when you have an or that faces each other, that's infinite solutions.